In the last video, we talked about finding displacements by making a scale model. And if you'll remember, we had this problem. All right, we had somebody walking 50 meters north, then turning and going 30 meters at an angle of 30 degrees. And then we found the resulting displacement. And we said that that was equal to about 42.5 meters at 53 degrees north of east was our answer. In this one, we're going to talk about another way of finding it, and we should end up getting the exact same answer since it's the same problem. And we're going to do it using the components of the vectors. An advantage of this is I don't have to draw out a scale model. So using the components, we're going to do 3 steps. We're going to find the components of the original vectors. Okay. Then we're going to find the components of the resultant. So the x component of the resultant we're going to find by adding the x components of the individual vectors. And the y component of the resultant, we're going to find by adding the y components of the original vectors. And then our last step is going to be to construct the resultant from our y and our x. Now, that may not make a lot of sense until we practice it one time. So we're going to go back to this problem. We have 50 meters going straight north, and then we have 30 meters at an angle of 30 degrees. I'm going to call this vector A over here, and I'm going to call this one B. That's to organize things. And I think it actually even helps sometimes to draw them separately. So here is A, which is 50, and here is B, which is 30 at an angle of 30 degrees. Now, my first step was to find the components of the original vector. So I have to find the components of A and the components of B. AX. Now, if I look at A, it's all in the y direction. None of it is in the x direction. So AX is going to be 0. And our AY is going to be 50, because all 50 of it is in the y direction. It's also going in the positive y direction, so it's going to have a positive sign. Now for B, I have to split that up into BX and BY. Now, these are vectors, so they have to be drawn as arrows. B is going to the right and down, so BX is going to be to the right, and BY is going to be down. Now, if I look at this, BX is the adjacent side, BY is the opposite side. So for BX, I'm going to use cosine because it's the adjacent side. So cosine of my angle is going to equal the adjacent side, BX, over my hypotenuse, which is 30. So then BX is going to be 30 cosine 30. So BX is going to equal 26.0. And then for y, it's the opposite side, so I would use sine. So sine of my angle is going to equal by over 30. So hypotenuse, by is going to be 30 sine 30. And by ends up being 15. Well, wait a minute, I got to check and make sure I have all of my signs right. AY is positive because it's going up. BX is positive because it's going to the right. But BY is going to be negative because it's going down, and that's the negative y direction. So I did my first step, and I found the x and y components of all of my vectors. So that was step 1. Step 2 is to find the x and y components of the resultant. So Rx, we're going to add all of the individual x components to get Rx. So AX was 0, BX was 26, so RX is going to equal 26. Then ry is ay plus by. It's equal to 50 plus negative 15. So it's important we had that negative there, or we were going to get this step wrong. And then ry is going to equal 35. Now our last step, it says construct the resultant from Rx and Ry. So the x component of the resultant is equal to 26. So that's telling me to go over this way, 26. Now the y component is 35, and it's positive, so we go up 35. And then my resultant displacement is just going to be here and down. I'm going to have to find that. I'm going to have to find the angle. But x's and y's are always at right angles. Okay, so now I can go back to the Pythagorean theorem. So finding r, I'm going to do r squared equals 26 squared plus 15 squared. And if I plug that all into my calculator, I end up with a resultant of 44 meters. And then I have to find the angle. I have the opposite side and the adjacent side. So tangent is opposite over adjacent. So I would do tan theta is the opposite, 35, divided by the adjacent, 26. Again, if I plug that into my calculator, I would do 35 divided by 26, and then inverse tangent. And if I do that, I end up with an angle of 53.4 degrees. And that's north of east, because here is east, and I swung up north of it to get that angle. So my answer is delta x is equal to 44 meters at 53.4 degrees north of east. And we said that should match what we got when we did it with the scale model. And it's very close. We had 42.5 and 53 degrees. Actually, doing it with this component way is a little more accurate because you won't have the measurement errors when you're making that you have when you're making the scale model. So now we should be able to find resultants two ways, by doing a scale model or by doing the components. The scale model, you don't have to do any trig, but with the components, you don't have to draw things out to scale.